Hey kiddos, today we're going to be talking about finding the area of regular polygons. Okay, so remember, a regular polygon basically means that all of the sides are congruent and all of the interior angles are congruent. Okay, that's what makes it a regular polygon. So the radius, which is here, of a regular polygon is the distance from the center to a vertex, which is your corners. The apothem of a regular polygon is the perpendicular distance, so that gives us that 90 degrees, okay, from the center to a side of the polygon. Very important that you understand and recall the difference here, okay? The area formula for a regular polygon is half the product of the apothem and the perimeter. So that means that we're going to have to know what the side is of a regular polygon so that we can figure out what the perimeter is. You'll take that value, multiply it by the apothem, and then you divide that answer by 2. So here's our formula. Okay, so let's look at our first example. So notice we have an 8-sided figure here, an octagon, and the side is marked as 12. So I went ahead and marked all the sides as 12. And you need to always make sure that you identify what you're given, whether it be the apothem or the radius. Okay, in this case, because it is from the center to a side, creating that perpendicular, that 90 degree here, then that means I know that that is my apothem. So the apothem here is 14.5. Now, one side is 12 and it's got 8 sides, so 12 times 8 gives me a perimeter then of 96. According to the formula, I'm going to take the apothem, which is the 14.5, and then multiply that by the perimeter, which is 96, and then I'm going to divide that by 2. So 14.5 times 96 is 1,392. Divide by 2 gives me an area of 696 units squared. Since they didn't specify centimeters, inches, feet, all that kind of stuff, we just put units squared. Moving on to the next one. This is a 5-sided figure, which is a pentagon. All right, and we're given the side length as 7.5. So notice I went ahead and write it on all the sides. And again, based here, what is given to us? Is it the radius or is it the apothem? Hopefully, because you see that 90 degree there, that is the apothem. So the apothem is 5.1. Perimeter, if I take that 7.5 and multiply by 5, gives me 37.5. So now let's plug it into the formula, which you're going to have memorized, which is the apothem times the perimeter, divide by 2. Yes, I said memorized. You can handle it. I believe in you. Which means we have 5.1 times 37.5, and we're going to divide that by 2. So 5.1 times 37.5 results in 191.25. And then when I divide that by 2, eureka, 95.6, because you already know I like to round to the 10th. Units squared would be the area of that pentagon. All right, so it's time for an oh-yo on your own. So you can handle this. Make sure you find the apothem. Make sure that's what you're given. Then find your perimeter. And then you can use the formula to get the area. So let's do this one together because I see we have a radical. So I figured we'd do this one together. This regular polygon is 6-sided. So one side is 10. So if I multiply that 10 times 6, I get the perimeter to be 60. I can clearly see that the apothem is given to us because it's from the center to a side, and I see 90 degree. So the apothem is 5 square root of 3. So when I work this out, and why not? For fun, we're going to keep it in radical form, and we'll actually also get the decimal form. Okay? Go big or go home, right? So you got 5 square root of 3 being multiplied by 60. We're going to divide that by 2. So 5 times 60 is the only thing you can do. And you keep the square root. And you divide that by 2, which 300 divided by 2 you can actually simplify. And you would end up with, in radical form, with an area of 150 square root of 3 units squared. Now, let's say I want the decimal version of that. All you got to do is do 150 times the square root of 3, and we get the decimal version answer of that to be 259.8 units squared as the area. So make sure you get both answers. All right, let's throw a little curveball at you. Curve. This time you're given the area of a regular polygon. So they're telling us that the area of this regular polygon is 60 inches squared. They want us to find the apothem. So we're going to have to revamp here our formula to help us find the apothem. So first, I notice that they do give me a side. That is very helpful because I need to know what the perimeter is. So if I just do 8 times 3, because this is 3-sided, I clearly get that that the perimeter is 24. We already know that the area is 60. Question is, what is the apothem? So let's plug in our values into the formula of what we know. We know that the area is 60. We don't know the apothem, but we do know that the perimeter is 24, and the rest of the formula is to divide by 2. So this is basic algebra. To get rid of that divide by 2, I'm going to multiply both sides by 2. So we end up with 120 equal to basically 24a, because 24 times a is 24a. So my next step here is to simply divide both sides by 24, so I can get the apothem, which is a, by itself. And when I do that, we get a value that the apothem is equal to 5. Yay. All right, so this time, again, we're given the area of this regular polygon, which has 9 sides, and its area is 297 meters squared. They want us to find the length of one side. So they're not asking us for the whole perimeter. They're just wanting to know what's the length of just one side. So we're given, as you can see here, the apothem. Yay. So that makes our life just a little bit easier because we're actually given a piece of information we can use. So that's 16.5. Got no clue what the perimeter is because I got to know what one side is in order to find that. So let's plug this into our formula and see if we can work backwards, essentially. So we would have the area, which is 297, equal to the apothem, which we do know is the 16.5. And we'll be multiplying that by the perimeter, divide by 2. As before, got to get rid of that divide by 2, so I'm going to multiply both sides by 2. 2 times the 297 results in 594 equal to 16.5 p. So to figure out what p the perimeter is, I'm just going to simply divide 16.5 to both sides. So those cancel out. Excuse me. 594 divided by 16.5. Ooh, love it when we get perfect numbers. Is 36. So the perimeter here is 36. Please do not tell me that is our answer, because that is not what the question was asking for. It says, what is one of the lengths of the side? So the length of one side is going to be founded by taking that 36, which is the perimeter, and dividing it by the number of sides that this regular polygon has, which is 9. And you would result with 4. So that is the final answer. That, my children, is how the cookie crumbles. All right, so on to the next. Find the area of the following. Find the area of the following regular polygons. All right, so the first one that we have here is, oh, yes, I know, our favorite shape, the triangle. Okay, and let's see, what do they give me? Oh, my. I know that the radius is 18. Now, I know this is radius because it's coming from the center into the vertex, into the corner. So that is not what I need to figure out the area, because I need the apothem and I need a side length so I can get the perimeter to use the formula. So, what do we do? Well, hopefully you recall that we can just simply draw in this apothem, because I know that's going to give me that 90-degree here, which tells me that this is a right triangle, which means we can work with this. Now, one slight problem, something you need to make sure that you know, and I'm telling you now, so be listening. The radius of a regular polygon bisects the angle, okay? So that's something that we need to make sure we know. So we got to use some prior knowledge here. What is the degree measure of these angles if this is a regular triangle? Well, hopefully you all know that that's 60. So what happens here is that creates this to become 30 and 30, which also means that we got a special right triangle on our hands, a 30, 60, 90, which I know you're super excited because now you get to use those rules to help us answer this question. So I'm going to draw that right triangle. 30, 18, there's the 60, there's my 90. And let's go ahead and label it. Across the 30 goes x, across the 60, x square root of 3, and across the 90 goes 2x. So if we solve that, we got 2x equals 18, divide both sides by 2, we get that x equals 9. So we discovered that the apothem is 9. All right, let's see. So that would mean that this portion would be 9 square root of 3. So let's see if we can figure out what the side length is. I think it's time we do a little investigating here. So do you all think that this apothem bisects the side? All right, so I'm going to go ahead and label that there. And you know what? We're going to make the assumption right now, because then we're going to prove it later, that the apothem actually bisects the side. Okay? So therefore, if that is 9 and square root of 3, then this would also be 9 square root of 3. So this side length would be 9 square root of 3 plus 9 square root of 3, or you could just do 9 square root of 3 times 2, which is 18 square root of 3. And for right now, we're just going to leave it in radical form and work it out that way. So now we got the side length. So since I have a side length, we can figure out what the perimeter is. So that would be simply taking that side length of 18 square root of 3 and multiplying it by 3, which gives us a perimeter of 54 square root of 3. And the apothem we discovered was 9. Let's say I want to change that radical 54 square root of 3 to a decimal. So I'd just do 54 times the square root of 3. And that would give me the decimal version of 93.5. So we're going to have both answers. So let us now find the area, which we have all the information we need. The area equals the apothem, which is 9, times the perimeter, which is the 54 square root of 3, divided by 2. 9 times 54, It's 486. And then if you divide that by 2, we get 243 square root of 3. Or if I change that into a decimal, 243 times the square root of 3 results in 420.9 units squared would be our area. So let's see if we can work backwards and discover if the perimeter, or sorry, if the side lengths are actually being bisected by this apothem. Okay, so I know this is a little extra, but y'all can follow along. So given that and just to make it easier on us, we're going to use the decimal version. Okay, so we may be off by a few hundredths or tenths. Okay, so given that the area is 420.9, okay, and given that we know the apothem is 9 times let's say we don't know the perimeter, okay, divide by 2. If we were to work this out, you'd multiply both sides by 2. So you get 420.9 times 2 to be 841.8 equal to 9p. We're going to divide both sides by 9. So when I divide that by 9, I get a perimeter of, wow, what do you know? 93.5. So notice this perimeter is matching up right now with this perimeter that we already got. If I take this perimeter and divide it by 3, you get a side length of 31.2. So let's check. Is 18 times the square root of 3 equal to 31.2? It sure is. So yes, we've just proven that an apothem, okay, from the center to the side of a regular polygon, that apothem does actually bisect that side. Oh, and this other problem right here, that's another, oh yo,